So good morning everyone. We'll continue with Milne Thomson method. So that day what we have done, and when is Milne Thomson method applied? When the Milne Thomson method is applied to find the analytic function when either u is given, that is the real part is given, or the imaginary part, or u plus v or u minus v is given. So the previous lecture we have seen how to calculate the analytic function when u was given. When the real part was given, we have calculated ux, uy, put x equal to z, y equal to 0, and then calculating f dash of z, which is ux plus ivx, and then integrating and getting f of z. The same thing, we are continuing with this when the imaginary part is given. How to proceed when the imaginary part is given and how to find the analytic function f of z. The first problem, find the analytic function whose imaginary part is v is equal to log of x square plus y square plus x minus 2y. Procedure is the same, slight change in the procedure, otherwise almost it is same. So v is equal to log of x square plus y square plus x minus 2y. Again, we have to find the analytic function, which means we have to find, we know that f of z is equal to u plus iv. Okay, so we are calculating the function f of z for which the imaginary part is log of x square plus y square plus x minus 2y. Okay, we are going to find the analytic function f of z for which the real part is v is equal to the given term. Okay, so the procedure remains the same. Since v is given, we will calculate first vx. Vx is the partial derivative of v with respect to x, keeping y as a constant. So then log derivative is 1 upon, so I'll get 1 upon x square plus y square into the derivative of x square plus y square with respect to x, that is 2x, plus x derivative is 1, y derivative is 0. So I will get vx is equal to 2x upon x square plus y square plus 1. Next we have to put, so what is the Milne Thomson method? What do we substitute? Do you remember what we have done when u was given? What do we substitute after calculating ux and uy? What was the substitution for the Milne Thomson method? You can write in the chat box what is the method. Yes, put x is equal to z, y equal to 0. Correct. The same procedure here also. Putting x is equal to z, y equal to 0. So what is the answer for vx at the point z comma 0? When I replace x by z and y by 0, I will get 2z upon, so I will get 2z upon z square plus 0 square plus 1. That will be equal to, put x is equal to z, y equal to 0. I will get 2z upon z square, y is 0, so plus 1 as it is. So I will get 2 upon z plus 1. The z and z will get cancelled. I will get 2 by z plus 1. This is vx at the point z comma 0. In a similar way, calculate vy. That is differentiating the given function partially with respect to y. So अभी y से differentiate करना है, तो we will get vy is equal to, again log derivative is 1 upon, derivative of x square plus y square is 2y, x derivative will become 0, and minus 2y derivative will become minus 2. So I will write vy is equal to, log is 1 upon, derivative of x square plus y square is 2y, x derivative is 0, and minus 2y derivative is minus 2. Same way, putting x is equal to, procedure remains the same. X is equal to z, y equal to 0. So when I put y equal to 0 in the whole expression, what remains in vy then? Minus 2, correct. So vy is equal to minus 2. Okay. Now, next is, our aim is to calculate f of z. To calculate f of z, we calculate first f dash of z. So what is f dash of z? By the given formula, what is the normal If f of z is u plus iv, what is f dash of z? How did we write f dash of z in general? When f of z is u plus iv, then f dash of z becomes ux plus I into vx. Ux plus I into vx. Okay, so I'll write f dash of z is equal to ux plus I into vx. Now what we have got for ux, what was ux in the previous step? We had ux as 2 by z plus 1 and vy as minus 2. And now we are having vx and vy. But in f dash of z, we are having ux and vx. U is not known to us. So now we have to make use of the CR equation and replace ux by vy to write f dash of z as vy plus I into vx. The reason is ux is not known. In the previous method, when u was given, we had converted vx in terms of uy. Now, since vx, vy are known to us, we have to convert ux in terms of vy. So, f dash of z is generally it is ux plus I vx, but if I change ux to vy, then I will get vy plus I into vx. This is f dash of z. Now substituting for vy and vx. So vy we got it as minus 2 and vx is 2 by z plus 1. So I'll write minus 2 plus I into 2 by z plus 1. Our aim is to get f of z. We have got f dash of z. Now integrating f dash of z to get f of z, that will be the final answer, finding the analytic function. So f dash of z is minus 2 plus I into 2 by z plus 1, integrating each term. So minus 2 derivative will become, integration will become minus 2z, 2 by z integration is log z, 1 integration is again z. So integrating, I will get the answer as minus 2z plus I into, it's 2 log z, right? This has to be 2 log z plus z, not there should be 2 log z, not I'll just change over here. It's 2 log z. Minus 2z plus I into 2 log z plus z plus c. Clear? Any doubt in this? Same procedure, only thing since v is given, we have to calculate vx and vy and then put x is equal to z, y equal to 0. And then writing f dash of z as, we know f dash of z is ux plus I vx. So, but we are not, ux function is not known to us. So, we are converting ux to vy and replacing vy and vx and then calculating the, integrating the function f dash of z to get f of z. Okay? Same procedure, whatever we have done to change kahan pe hai, if v is given vx vy and change is only in this part. F dash of z will become vy plus I vx because we cannot keep ux in f dash of z. As ux we cannot calculate because the real part is not known to us. Just everything is same. The next problem. V is equal to x minus y upon x squared plus y squared. V is equal to x minus y upon x squared plus y squared. Same procedure, calculating Vx, Vy, putting x is equal to z, y equal to 0. तो सबसे पहले हमें डिफरेंशिएट करना है v को x से, keeping y as the constant. So again to get Vx, we will apply u by v method of differentiation. So it is v du minus u dv upon v square. So vx will become v du, denominator into the derivative of numerator with respect to x, that is 1, minus u into, that is x minus y, into derivative of v, which is 2x, upon v square, that is x square plus y square, the whole square. So next we can put x is equal, we need not simplify this part because it's only to calculate vx at the point z comma 0. So I'll put x is equal to z, y equal to 0. Then x is z, y is 0, replacing x by z. So I get z square plus 0 minus z minus 0 into 2z. So this y terms will become 0. So here we'll get z square will remain in the first term, and in the second term minus 2z square will remain. It's z square in the first term and minus 2z square in the second term. So if I write that, I will get z square minus 2z square, and z square minus 2z square is minus z square upon the denominator, that is equal to minus 1 upon z square. So Vx at the point z comma 0 is minus 1 upon z square. Similarly, calculate Vy. Differentiating V partially with respect to y. Differentiating V partially with respect to y. Again, u by v method, x will remain as a constant. u by v में फिर से v du minus u dv upon v square. So v du, derivative of x minus y with respect to y, that will become minus 1, minus u into derivative of v, that is 2y, upon denominator v square, that is x square plus y square, the whole square. Again, put x is equal to z, y equal to 0. Tell me what will be Vy then. When I put x is equal to z, y equal to 0, tell me what will be the value of Vy at the point z comma 0. First term will become minus z square, है ना? यहाँ पे minus z square because y की value 0 है. So I will get minus z square, y is 0, so second whole term will become 0 here. X is z square, y is 0. So I will get minus z square upon z square, the whole square. That will be minus z square upon z raised to 4. Okay, minus z square upon z raised to 4, which is also equal to minus 1 upon z square. Okay, that is also equal to minus 1 upon z square. So Vx is minus 1 upon z square. This is Vy. Again, there is a mistake here. This is Vy. That is Vy. So Vx is minus 1 by z square. Vy is also minus 1 by z square. Substituting in f dash of z and calculating f of z. You don't have to simplify all these. Just use u by v and carefully think. Just see to it that you're differentiating with respect to which variable. That is only important. And then putting x is equal to z, y equal to 0. So in the next step, I write f dash of z is equal to ux plus ivx. And since ux is not known, again, CR equation, replacing ux by vy. Okay, we are having ux here, but we know ux is equal to vy from the CR equation. So I can replace ux by vy in this f dash of z, substituting for vx and vy, and then integrating the function to get f of z. Vx, Vy both are minus 1 by z square. So replace Vy by minus 1 by z square, Vx also by minus 1 by z square, and then integrate both the terms and to get the value, to get the function f of z. Substitute कर रही हूँ Vy और Vx के functions को. Since minus 1 by z square is common, I can take it out. The remaining will be 1 plus I. The constant term is 1 plus I. And now integrating. So 1 plus I is the constant. So integration of minus 1 by z square. What is that? What is the integration of minus 1 by z square? One by z. Yes, plus 1 by z. See, normally what we find the mistake in these type of problem is the integration and differentiation formulas are mixed. See, sometimes we make use of integration formulas in derivative part and sometimes here. That is a common mistake we find in the exam. So be careful what you're doing here. Differentiate, because in this problem we have to differentiate and integrate. So don't confuse between the formula. That is only important here. So minus 1 by z square integration is 1 by z. So f of z will become 1 plus I into 1 upon z plus c. 1 plus I. Yes, it's a constant, no? It's not, it is independent of z. So 1 plus I is the constant. If you have the function z, then only you have to integrate that function z. 1 plus I is not having any z in that. Okay? So it's a constant. It's just like it's a complex constant in this case. Normally we have 2, 3 and all. Here it's a complex constant. 1 plus I is a complex. Because we're dealing with complex variables here, you can have complex constants here. Nothing wrong. Only thing, if you have that constant in the denominator, then multiply and divide by the conjugate to get, you always keep the denominator part as a real number. Since here 1 plus I is in the numerator, we did not do anything. But suppose you have 1 upon 1 plus I, something like that. Then you have to multiply and divide by the conjugate and make the denominator as a real number. That has to be done. Okay? Okay. The next problem. V is equal to tan inverse of y by x. V is equal to tan inverse of y by x. Differentiate. So what is the derivative of tan inverse? Derivative of tan inverse of x. It is 1 upon 1 plus x square. Tan inverse of x का derivative है 1 upon 1 plus x square. Here we have tan inverse of y by x. So it will be 1 upon 1 plus y by x the whole square into the derivative of y by x with respect to x. ठीक है? Tan inverse का derivative is 1 upon, अगर यहाँ पे x है तो यहाँ पे x आता है. So it is y by x है, so I will get 1 upon 1 plus y by x the whole square into the derivative of y by x. Now y is the constant, x is the variable. So y into 1 upon x का derivative will become minus 1 upon x square. So I will get 1 upon 1 plus y by x the whole square into minus y by x square. Okay? We are differentiating with respect to x. So y will remain as a constant. So y into derivative of 1 by x. And 1 by x का derivative होता है minus 1 by x square. Now simplify, take the LCM. So now if I take the LCM in the denominator, I will get x square plus y square whole thing upon x square. That x square will go to the numerator and will get cancelled with this x square. So the remaining part will be minus y upon, even if you don't keep it, it's okay, you can directly put x is equal to z, y equal to 0. You need not simplify this part also. It's better to simplify, otherwise you will, that's also fine. You can do substitution directly also. तो पूरा 0 हो जाएगा शायद ना, if I don't simplify that. ये 0 ही होंगे, answer is 0. Answer is 0, correct. Vx is equal to 0. When I put x is equal to z, y equal to 0, the answer is equal to 0. Simplify नहीं किया तो भी चलेगा. It is not compulsion. I simplified in this case. It's not required. Okay, let's see. Vy is 1 by z. Let's try that. So now differentiate v partially with respect to y. So when I differentiate partially with respect to y, ये term तो same रहेगा. So what is the derivative of y by x with respect to y? What is the derivative of y by x with respect to y? One by x, correct. That is 1 by x. So when I differentiate vy, the first term will remain the same. Derivative of y by x with respect to y will become 1 by x, because 1 by x is a constant. Derivative of y will become 1. Now put x is equal to z, y equal to 0. When I put x is equal to z, y equal to 0, z upon z square, that is equal to 1 upon z. Even if you don't write this step, if I put y is equal to 0 here, the whole term will become 1. Then put x is equal to z, I will get 1 by z. Even if you don't do this step directly also, we can write put y is equal to 0. So ये हो जाएगा 1 upon 1 plus 0, that is 1. And then 1 upon z, that is answer is 1 upon z. So directly substitution is much better than simplifying and substituting. So next one. So we have calculated Vx and Vy. Now substituting in f dash of z, that is ux plus ivx. Again, we are not knowing ux function, so we will convert ux to Vy. That is equal to Vy plus I into Vx. So Vy is equal to, what is the answer we have got? Vy is equal to 1 by z and Vx is equal to 0. Okay, so Vy is equal to 1 by z, Vx is equal to 0. If I substitute that, f dash of z will become 1 upon z. F dash of z is 1 upon z. Then integrating f dash of z to get the function f of z, which is equal to log z. F dash of z is 1 by z, so f of z will become log z plus c. That also I told you, log z का जो real part है, that is half log x square plus y square, and the imaginary part is tan inverse of y by x. Because log of x plus iy is defined in that manner. Log of x plus iy is half into log of x square plus y square plus I into tan inverse of y by x. And we were given the imaginary part as tan inverse of y by x, which means हमें वो function निकालना है जिसका imaginary part tan inverse of y by x होगा. So we have found f of z is equal to log z because log z has the imaginary part tan inverse of y by x. doubt in this? Clear? V wala part B, when V is given, calculating Vx, Vy. Next problem. Just try this. Vx nikalo, put x is equal to z, y equal to 0. Differentiate V partially with respect to x. Just try karo and tell me what is the value of Vx. I will show you, but just you try it. Differentiate V partially with respect to x. क्या होगा? Calculate that. Find Vx. डायरेक्ट फंक्शन है, हमें हर एक टर्म को डिफरेंशिएट करना है x से, y को कांस्टेंट रख के. So what will be Vx? After putting x is equal to z, y equal to 0. It is 4z cube minus 2z. Okay, let's see. What about others? पहले x से डिफरेंशिएट करना है, उसके बाद x को z पुट करना है और y को 0 पुट करना है. So let me see what are the other answers. One answer I've got 4z cube minus 2z. Okay. Okay, Tejas and Yash have got the same answers. The plus he is getting. Okay. Tejas has got negative. Samir plus. Okay. Samruddha also plus. Uttara plus. Okay. ठीक है, विल ट्राई दैट. तो हमें क्या करना है? Vx इज इक्वल टू, इसको हमें डिफरेंशिएट करना है. तो x raised to 4 is 4x cube, 6x square, that will become minus 12x, y square remains as it is, y raised to 4 का 0 हो जाएगा, x square का 2x, इसका 0 हो जाएगा, 2xy का 2y. Put x is equal to z, y equal to 0. जहाँ पे y का टर्म है वो पूरे 0 हो जाएंगे. तो I will get only 4z cube plus 2z. Okay? Plus 2z. Yes, it's plus pages. Yes, correct. ठीक है. Now dy बताओ क्या होगा? v को अभी y से डिफरेंशिएट करना है. 2z. ओके, ठीक है. y से डिफरेंशिएट करना है मतलब x का जो पार्ट है वो कांस्टेंट हो जाएगा. तो x रेज टू 4 का डेरिवेटिव 0, y स्क्वायर का डेरिवेटिव 2y, इसका हो जाएगा 4y क्यूब, ये 0 और ये minus 2y and last one is 2x. So I will get this term 0. X square is 6x square is the constant. Derivative of y square will become 2y. तो यहाँ पे हो जाएगा minus 12x square y. इसका 4y cube. X square का 0 minus 2y and derivative of 2xy with respect to y will be 2x. Again put x is equal to z, y equal to 0. When x is equal to z, y equal to 0. यहाँ पे y का टर्म है, यहाँ पे y का टर्म है, यहाँ पे y का टर्म है. तो ये तीनों टर्म 0 हो जाएंगे. So I will get only Vy is equal to 2z. Correct. Now substitute everything in f dash of z. Vy का 2z है, Vx का 4z cube plus 2z. So substituting everything in f dash of z, ux plus ivx. Again changing ux to Vy. जो हमें पता है वो फंक्शन चाहिए वहां पे. अगर ux uy पता है तो पूरा f dash of z ux uy में कन्वर्ट करना है. And if you are knowing vx vy, then convert ux also in terms of vy. Substituting for vx and vy. Now integrate. तीन terms है, तीनों को again I is the constant, so integrate the terms containing the z part. So 2z का integration will be, 2 is the constant, z का integration z square by 2. 2 into z square by 2, that will become z square. Similarly 4z cube. 4 is the constant, z cube का integration z raised to 4 by 4. That will become only z raised to 4. यहाँ पे भी 2 into z square by 2. So I will get z square plus I into z raised to 4 plus z square plus c. ठीक है, इनको बोझकर you will find there within phi 1, phi 2. I have not changed the variable, that was just vx and vy only. Because वहाँ पे phi 1 define किया है, phi 2 define किया है. Method is the same, but they have done by phi 1, phi 2 and then calculated. But I thought why to simply change the variables again. It's already vx and vy, we'll keep it in the same thing. Don't confuse there. The same method, only they have used different variables for vx. They have taken that vx is equal to phi 1, vy is equal to phi 2, and then they have done that. Next question, v is equal to sin h2y upon cos 2x plus cos h2y. Calculate what is the derivative of sine hyperbolic function. Sin h2y का derivative क्या होता है? या with respect to, otherwise just tell me what is derivative of cos hyperbolic function. कोई भी variable रहने दो. Derivative of cos hyperbolic, cos h का derivative. Manish, you have got minus 2z, which was the previous problem, na? Okay, plus, ठीक है. Yes, yes, correct. Cos h2y का derivative is sin h2y. There is no minus sign when we differentiate cos hyperbolic function. And sin h2y का cos h2y into 2. Okay? There is no minus sign when we differentiate cos hyperbolic. Cos का derivative minus sign है, but cos hyperbolic का derivative sin hyperbolic है. Okay, so now calculate Vx. Try just use u by v and tell me what will be the answer then. Slowly you do it. Differentiating v partially with respect to x. ठीक है? तो u by v use करना है. v du minus u dv upon v square. Just write v du minus u dv upon v square and put x is equal to z and y equal to 0. बताओ क्या होगा आंसर vx का. जस्ट यूज u by v. पहले v लिखना है, फिर डेरिवेटिव ऑफ u माइनस u इंटू डेरिवेटिव ऑफ v अपॉन v स्क्वायर. Don't simplify. Put x is equal to z, y equal to 0. Okay, what is the value of cos z 0? That day also we have done. What is cos h 0? That is 1. Sin h 0? 0. Correct. So sin, yes, correct. Sin h 0 is 0, cos h 0 is 1. So what will be the answer for Vx now? When I put cos h 0 as 1, sin h 0 as 0, what is the Vx function differentiating cos 2x plus cos h 2y into the derivative of sin h 2y? There is no x function here and we are differentiating with respect to x. तो ये 0 हो जाएगा माइनस u इंटू डेरिवेटिव ऑफ v. cos 2x कांस्टेंट है, cos h 2y का डेरिवेटिव सॉरी x का डेरिवेटिव cos 2x. यहाँ पे cos वेरिएबल है ना, तो cos का डेरिवेटिव विल बिकम माइनस 2 sin 2x अपॉन v स्क्वायर. अगर मैंने x को z पुट किया, y को 0 पुट किया, तो सेकेंड टर्म ये टर्म पूरा 0 हो जाएगा. यहाँ पे ये हो जाएगा, ये भी 0 हो जाएगा पूरा, है ना. So everything is 0. So I will get Vx to be equal to 0. Okay. Now calculate Vy. Same way, differentiating V partially with respect to Y. Differentiating V partially with respect to Y. Again use U by V and put x is equal to Z, Y equal to 0. Okay, tell me what is Vy. So Vy, again V into du. Du is sin h2y का derivative. That will become 2 cos h2y minus u into derivative of V. That is equal to 2 sin h2y upon cos 2x plus cos h2y the whole square. Put x is equal to z, y equal to 0. This term will become 0 because sin h 0 is 0. ये पूरा term 0 हो जाएगा. यहाँ पे cos h will become 1, ये भी 1 हो जाएगा. So I'll get Vy is equal to, this is 1, cos h is 1, so I will get 2 outside. This is cos 2z plus 1 upon cos 2z plus 1 the whole square. This part is 0 because sin h 0 is 0. ठीक है, ये पूरा टर्म 0 हो गया, ये 1 हो गया, ये 1 हो गया, तो बचेगा 2 into cos 2z plus 1 upon cos 2z plus 1 the whole square. तो यहाँ पे 1 cos 2z plus 1 कैंसिल हो जाएगा, so we'll be having 2 upon cos 2z plus 1. 2 upon cos 2z plus 1. Okay. Again, our aim is to integrate in the end. So try to use trigonometric formulas in the denominator and convert 1 plus cos 2z. 1 plus cos 2 theta is equal to 1 plus cos 2 theta is equal to is it sine square or cos square? Yes. 1 plus cos 2 theta is 2 cos square theta. 1 minus cos 2 theta is 2 sine square theta. Okay? So here 1 plus है तो इसीलिए cos square आ जाएगा. 1 minus होता है ना यहाँ पे तो sine square आता है. So here I will get 1 plus cos 2z as 2 upon 2 cos square z. Okay, 1 plus cos 2 theta is 2 cos square theta. 2z नहीं आएगा again. Okay, 2 cos square z. अगर 2z है तो z आता है यहाँ पे. Write the formula for cos 2 theta. What is cos 2 theta? It is cos square theta minus sine square theta. Convert sine square is 1 minus cos square. From that you get that formula for 1 plus cos 2 theta. Okay, it is not 2z. I think all of you have written 2z there. So 1 upon 2 cos square z, that is equal to sec square z. अच्छा सॉरी स्क्वायर है. ओके ओके, बहुत कंफ्यूजन होता है. ठीक है ठीक है ठीक है. यस यस गॉट इट. बहुत कंफ्यूजन होता है व्हेन यू राइट दैट रेस 2 ना, उसके बाद 2 जब आता है तो लगता है कि 2z है वो. ओके फाइन. ठीक है, तो वी गॉट Vy is equal to sec square z. Vx is equal to 0. Substitute everything in f dash of z. Integrate. सेम थिंग, ये सब सेम स्टेप्स ही है. Vy का जो है we got answer as sec square z and Vx is equal to 0. Integrating sec square z का इंटीग्रेशन. याद है व्हाट इज sec square z का इंटीग्रेशन, या कौन से फंक्शन का डेरिवेटिव sec square z आता है? यस, tan z. sec square z का tan z. Therefore z will become tan z plus c. So tan z का imaginary part is the given function. Okay, tan अगर x plus iy हम करेंगे ना, and when we multiply and divide by the conjugate and all those things, we will get that as the answer. Tan z का जो imaginary part है, that is the given function. Sin h2y upon cos 2x plus cos h2y. Okay, this was done. This was there in first semester again. Separation of real and imaginary part for sine, cos, and tan function. But normally for tan function, we don't put it in this manner. We normally take it as a different procedure we follow for tan function. But otherwise, this is the real and imaginary part of tan z. You can have one more problem. तो कैसे डिफरेंशिएट करना है इसको? I told you in the previous lecture also, keep bracket term as one function. ठीक है? It's up to you. You can define in any manner, but normally what I do is e raised to x को मैं एक term लेती हूँ, बाकी bracket term को मैं second term consider करती हूँ. Move into v I apply. You can take e raised to minus x with 4 terms हो जाएंगे. Just to avoid that, what I do is e raised to minus x as one term, and the bracket term is the second term. So apply u into v. Do it carefully. Vx, पहला e raised to minus x into derivative of the bracket term plus bracket term into derivative of e raised to minus x. और देखना है कि कौन से वेरिएबल से हम डिफरेंशिएट कर रहे हैं. तो अगर कॉस द y वेरिएबल्स ऑलवेज बिकम 0. Vx पहले मैंने लिया है e raised to minus x. ब्रैकेट टर्म का डेरिवेटिव विथ रिस्पेक्ट टू x. तो फर्स्ट टर्म का डेरिवेटिव विथ रिस्पेक्ट टू x. 2 कांस्टेंट है, y कांस्टेंट है, cos y कांस्टेंट है. तो 2y cos y is the constant, only x is the variable, and derivative of x will become 1. तो इसका डेरिवेटिव हो गया 2y cos y. यहाँ पे sin y is the constant, y square. तो sin y as it is you will get y square minus x square का derivative with respect to x will become minus 2x. Then bracket term as it is into derivative of e raised to minus x, which is minus e raised to minus x. ठीक है, I've just taken bracket term as v function, e raised to minus x as u function. So just use u into v. So what is the, now put x is equal to z, y equal to 0. Tell me what is vx. What will be vx when I put x is equal to z, y equal to 0? आई थिंक हर एक टर्म में y है शायद, जब sin y है. यहाँ पे y है तो y की वैल्यू 0 है, तो ये टर्म 0. यहाँ पे sin y है, sin 0 is 0. यहाँ पर भी y है, that is 0. यहाँ पर भी we are having either y or sin y का term, and then y is equal to 0, the whole terms will become 0, so we will get vx is equal to 0. Correct. In a similar way, calculate vy. Now when we calculate vy, e raised to minus x is the constant. तो खाली ब्रैकेट टर्म को हमें डिफरेंशिएट करना है. e raised to minus x will remain as it is. So in the next step, vy, differentiating v partially with respect to y. Okay, so here e raised to minus x will be a constant. in differentiation of the bracket term, again x will also remain as a constant. So vy में ये term वैसे का वैसे ही रहेगा. First term is 2xy cos y. Again 2x is the constant. Okay, 2x is the constant. Y cos y का derivative. Y cos y का derivative will become y into derivative of cos y, which is minus sin y, plus cos y into derivative of y, which is 1. ठीक है? So 2x is the constant in the first term of the bracket. Y cos y के लिए हमने u into v अप्लाई किया इसके अंदर. प्लस यहाँ पे भी u into v कर लो. y स्क्वायर माइनस एक्स स्क्वायर का को एक टर्म ले लो, sin y को सेकेंड टर्म. अगेन y स्क्वायर माइनस एक्स स्क्वायर derivative of sin y, which is cos y, plus sin y into derivative of y square minus x square, that is 2y. ठीक है? Do it systematically, you will get the answer. It's not a difficult topic. Systematically, हमें differentiate करना है. Just to do it systematically, you will get the final answer. ठीक है? Vy के बाद put x is equal to z, y equal to 0. देखो क्या आता है आंसर. Vy when x is z, y is 0. When x is equal to z, y equal to 0, here we'll get e raised to minus z. This is 2z. This is 1. This is 0. This is 0. Z square 1. And the next last term is 0. So I'll get e raised to minus z. 2z cos y is 1. ये 0 है. Plus y square is 0. Y is 0. Yes. Substituting everything in f dash of z. Substituting everything in f dash of z. Same thing again. Dy is e raised to minus z, 2z minus z square, and dx is equal to 0. Integrate. Hope you remember how to integrate that function. Integration by parts or UV rule, we have done it directly without using the formula. This is done. This method is applied when we have an algebraic function. So here also we are having 2z minus z square as an algebraic function, e raised to minus z as a what is that? Exponential function. तो इसको u लेना है, इसको v लेना है. फिर कैसे करना है? That day I told you, hope you remember. पहले हमको लिखना है u integral v. तो u का फंक्शन as it is, पहले u लिखना है, फिर इंटीग्रेशन ऑफ v लिखना है. सेकेंड टर्म इज माइनस. फर्स्ट टर्म इसका डेरिवेटिव, u का डेरिवेटिव. तो u का डेरिवेटिव हो जाएगा 2 माइनस 2z. फिर ये सेकेंड ब्रैकेट टर्म का इंटीग्रेशन. तो माइनस e रेज टू माइनस z का इंटीग्रेशन इज e रेज टू माइनस z. थर्ड टर्म इज अगेन पॉजिटिव. इसका डेरिवेटिव 2 माइनस 2z, 2z का डेरिवेटिव माइनस 2. इसका इंटीग्रेशन माइनस e रेज टू माइनस z. Go on differentiating the u term and integrating the integral v term till the derivative of. अभी next step actually minus आएगा यहाँ पे, लेकिन 2 का डेरिवेटिव 0 हो जाता है, तो we are not writing those steps. ठीक है? First term positive, second term negative, third term positive. It's alternate plus and minus. Starts with positive, negative, positive. Next term will be negative. It is minus, then derivative of minus 2. That will become 0. So we are not writing the next step. Till the derivative of u becomes 0, continue that process of integration by parts. इसे हमेशा ब्रैकेट में ही लिखो. Don't try to adjust this minus sign with this minus sign. ऐसे का ऐसे, so that you will not make any mistake. u को लिखो यहाँ पे, माइनस इंटीग्रल v को लिखना है, एंड देन इसको डिफरेंशिएट करो, अलग से ब्रैकेट में ही करो. सिंप्लिसिटी डू इट इन द एंड. कभी कभी ऐसा माइनस को अगर एडजस्ट करो तो देयर इज अ पॉसिबिलिटी ऑफ गेटिंग अ रॉन्ग आंसर. Sometimes it happens that when you try to adjust that minus, it becomes wrong. It's better Keep everything in the bracket term and integrate that. Simplify. Now we can take e raised to minus z common. If we take e raised to minus z common, this minus sign is remaining. So minus 2z plus z square minus 2 plus 2z, and this is plus 2. So 2 and minus 2 gets cancelled. 2z and minus z. Now it will be plus in the middle term due to minus e raised to minus z. Which middle term is telling? That's what I'm saying. I am not adjusting the sign. That's why I told you this is as per the formula. So I've kept everything in bracket only. Okay? Even we can adjust this minus sign. So I'm not adjusting the minus sign. What I'm doing is I'm keeping it as it is. Later on I'm simplifying it. So पहले u लिखा है, फिर इंटीग्रल v लिखा है, then minus. This is the formula. U का derivative, इसका integration. इसका derivative, इसका integration. See, that is why I have not written that. I have not adjusted the minus sign. जैसा है वैसे के वैसे ही मैंने differentiate और integrate किया है. With alternate plus and minus in between the terms. Okay, so answer is z square e raised to minus z plus c. So I think only z square will remain, right? Minus 2z cancels, 2 also cancels. So they will get e raised to minus z into z square plus c. Okay? So don't try to adjust that term. It's up to you. You will get the same answer, but sometimes there is a possibility of making mistake there. तो मैं हमेशा ऐसे बोलती हूँ कि just write the functions as it is. U लिखो, integral v लिखो. Second term negative. इसका derivative, इसका integration. इसका derivative, इसका integration. And then the second step, we try to simplify those minus and plus signs. Okay, hope now you're clear with the integration by parts wala formula when you are having u as an algebraic function. Because algebraic function only becomes 0. So we can apply this method of integration by parts, generalized rule of integration by parts. Okay, any doubt in this? Yes, your doubt is clear now? Okay. Two problems you can take for practice. Similar type we have done in U also, only slight difference here with respect to V it is given. V is equal to cos x cos hy and V is equal to e raised to minus x into x sin y. Similarly, similar problems we have done with respect to u. Just try with V also. Almost the same. I think यहाँ पे sin x था, यहाँ पे cos x है. Try this and see whether getting the same answers or not.